Hi future doctors, welcome to the next class. We were discussing Bernoulli's principle. So what is the Bernoulli's equation we say? P plus rho g h plus of rho v square equal to constant. What is P there? P is going to be not pressure, but pressure energy per unit volume. Rho g h, potential energy per unit volume. Of rho v square, kinetic energy per unit volume. So how these terms are going to be different in different cases, we will see now. So same, this equation we can write like this. P by rho plus GH plus V square by 2 equal to constant. What you might have observed means we have divided with this equation both sides with the density. Now what is this P by rho? P by rho is having one name. What is P we said? Pressure energy per unit volume. What is P by rho means? So pressure energy per unit mass. P by M by V. M by V is going to be written as rho. Now what is P by rho term? Pressure energy per unit mass. Now what is GH? Rho GH. Potential energy per unit mass. What is potential energy? mgh by m. So m will be cancelled. Now what is gh? Potential energy per unit mass. Next, what is v square by 2? Kinetic energy per unit mass. M will be cancelled. So this equation is going to be saying pressure energy per unit mass, potential energy per unit mass, kinetic energy per unit mass. Same like this. Pressure energy per unit weight, PV by mg they will say. So potential energy per unit weight, mgh by mg. Kinetic energy per unit weight of mv square by mg is always constant. Now if you observe this, again this v if you write here p by rho g, because m by v we can write it as rho. P by rho g plus, so mg will be cancelled, h plus m will be cancelled, v square by 2g is going to be constant. So all these three equations we are going to say Bernoulli's principle. What is conserved? We said what is the significance of Bernoulli's principle means. So all these are energies: pressure energy, potential energy, kinetic energy. Therefore, energy is going to be conserved. We will say. Now these terms we will say different terms. What are these terms name means? P is pressure head, rho gh gravitational head, of rho v square velocity head. Sometimes only this term they are going to ask. A fluid is flowing, ideal fluid is flowing in a tube of flow, then what is the kinetic energy per unit volume they will ask. Kinetic energy per unit volume means you have to calculate of rho v square. Simply they will give rho and velocity. Let us assume, so if you are opening a water tap, so in the tap, ideal fluid is going to be flowing with velocity 10 meter per second. So what is the kinetic energy per unit volume of that liquid they are asking. So kinetic energy per unit volume means how much kinetic energy within that volume we have to calculate. That is only half rho v square. What is the density of water? 1000 kg per meter cube. Velocity is going to be 10 square. That is kinetic energy per unit volume. So the pipe is at some height. Height they will give 10 meters. So what is the potential energy per unit volume? So pressure, how much pressure is going to act? That is going to be, so how much pressure? Energy per unit volume. So for this, they are going to write for horizontal pipe which is having different heights, or different heights without horizontal pipe, how they are going to write means H1, H2. So velocity of fluid V1, V2, pressure P1, P2. At the time, this equation they can write it as P1 plus rho g H1 plus half rho V1 square is equal to P2 plus rho g H2 plus half rho V2 square. For the horizontal pipe, if pipe is going to be horizontal, so for the horizontal pipe, what will be same means heights are going to be same. At the time, there is no height term. At the time, they will write, so P1 plus half rho V1 square equal to P2 plus half rho V2 square. So P1 minus P2 is equal to half rho V2 square minus V1 square. This equation only they will say aerodynamic lift. So delta P, pressure difference of rho. Sometimes they will take common V1 square, then V2 square by V1 square minus 1. Sometimes they will take common V2 square. Whichever velocity they are giving, depending on that we will take common. And for this equation of continuity also they are going to apply. A1 V1 is equal to A2 V2. So by taking this equation, V2 by V1 can be replaced as V2 by V1 can be replaced as A1 by A2. So same aerodynamic lift of rho V1 square into V2 by V1 means A1 by A2 whole square minus 1. This is very important equation. On aeroplane wing, according to Bernoulli's principle for horizontal pipe, we will write this equation. From this equation, P plus of rho V square equal to constant. So from this equation, P is equal to minus half rho V square. We are going to get constant if we are taking. So where velocity is more, their pressure is going to be less. Those are only we will say applications of Bernoulli's principle. So during cyclone time, so roof of this poor house is going to be fly off because during cyclone time velocity of the air is more on the top of the roof, at the bottom velocity is going to be less. Where velocity is more, pressure is going to be less. Where velocity is going to be less, pressure is going to be more. Therefore, it will be lifted upwards. During fast bowling and spin bowling, fast bowling, so top and bottom flow of fluid will be same, air will be same, velocity will be same. Therefore, there is no pressure difference. But during spin bowling, so top it is going to be more, velocity of the fluid will be more, at bottom it is going to be less. Therefore, aerodynamic is going to be, lift is going to act. Therefore, spin bowlers are going to take more wickets than fast bowlers. This is the reason according to Bernoulli's principle. Where velocity is more, their pressure is going to be less. If you are taking two papers parallel like this, if you blow air in between these two, papers will be coming towards each other. They will not go far away. So in your house, whenever ceiling fan is rotating, so calendar papers will be going away like this, away from the wall, because velocity of the air is more here, therefore pressure is less. Here velocity of the air is less, therefore pressure is going to be more. So therefore papers will be moving away from the wall. So if you are standing in front of the fast moving train, if train is moving like this, between you and train, so air flow will be more. So at your back side, so air flow will be less. Therefore, so you will be pushing towards the train because of this Bernoulli's principle. And aeroplane wing they will prepare in such a way that, so on the top of the wing, velocity of the air is going to be more, at bottom velocity of the air is less, therefore aerodynamic lift is going to be happening. So every takeoff flight below the wings, Bernoulli will be present. Next, during two boats are traveling in a fluid with very fastly like this. Then here velocity of the fluid will be more. At the time, two boats will get touch and they are going to get accident. This is also because of Bernoulli's principle. So venturi meter, scent spray, body sprays and mosquito hits, all these are going to be working on Bernoulli's principle. Where velocity is more, their pressure is going to be less. So they will ask some questions on this. Like this it will be there. So these are the pipes. So this is area of cross section. This is another area of cross section. Where velocity of liquid is going to be more means where area is going to be less, their velocity is more. Where velocity is more, their pressure is going to be less. They will take another two capillary tubes like this, where liquid is going to rise more height. Where area of cross section is less, their velocity is going to be more. If velocity is going to be more, pressure is going to be less. Therefore, here liquid will rise up to small height. Here velocity of area is more, therefore area is more here, velocity is less. Velocity is less means pressure is going to be more height it is going to rise. That type of questions also will be helpful. So you have to follow blindly area and velocity, latter pressure. So velocity is more means area is less. Area is less means velocity will be more. Velocity is more means pressure is going to be less. So if you follow this, definitely you will get problem on this aerodynamic lift, very important equation, that is for horizontal pipe. This is how to apply the Bernoulli's equation and different terms of Bernoulli's equation. Next we will see, next class we will see Torricelli's principle.